So we have a way of simulating the birthday problem. We use this function and we sample the numbers 1 to 365. We get 20 numbers between 1 and 365, and we look to see if any numbers match. And if there's a match, that represents 2 people sharing a birthday in our group of 20. And if each of the 20 numbers is unique, that represents no one sharing a birthday. And our goal is, or our plan is, to just run this code a vast number of times and then count the numbers of times we get a match versus the number of times we've run this code in all. And that gives us an estimate of the probability of 2 people in 20 sharing a birthday. But we have 2 interrelated problems. The first is we need a way of automating whether there is a match or not. We can't look through this. As I said in the last video, that would be incredibly tedious and it would take a very long time. The second problem is even if we automate that process so that we know whether there's a match, we need a way of running this code a great number of times. We can't possibly sit here and click this button hundreds or thousands or tens of thousands of times. So how are we going to do that? The first thing that we're going to do is, rather than just print this output to the bottom to the console here, we're going to actually save this output to a variable. So what I'll do is I'll just type out what we're going to do and then I'll explain it. So you can see that I've given this variable a name, and I've called it birthdays. You can call it anything you want. It doesn't matter, but I've just chosen birthdays because these numbers are going to represent our birthdays. You can see that after that I've put a less than and a minus sign. And what that does is it's going to take this output, these 20 numbers, and this is the assignment operator in R. So it's going to assign that to the variable birthdays. So if we run this code, you'll see that unlike before, we don't get any output down here. It shows us what we have ran, but we don't get the output of those 20 numbers here. Instead, you can see at the top right, we have under values, we have a variable called birthdays. It tells us that it is a variable of integers, tells us that there are from 1 to 20 of them, and we can see the first values there. Now that we actually have these values saved, we can use this this variable as an input for other functions, similarly to how we had these inputs here. And I'll show you what I mean. So our basic strategy here is going to be to use 2 functions, and we're going to use those together as a way of detecting whether or not there's a match here. And the way we're going to do this, so I'll just go ahead and type it out and then I'll explain it. Okay. So you can see that what I have are 2 nested functions. So I have this first function here called unique. And again, we can run this just to see what happens. And you can see that when you do that, what we get is all of the unique numbers that were in birthdays. So if we have, for example, 20 unique birthdays, we should get 20 numbers here. So let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you can see we only have 18 unique numbers in our birthdays variable. That means that there must have been some matches. There must have been numbers that were the same. And if we, down here, quickly type birthdays, let's see. So you can see that 298 has appeared twice. And there must be some other numbers that appear twice, but I'm not going to go through this. So this unique function, when you give it some numbers, it outputs just the unique numbers. It won't duplicate any. So in this case, again, what was it? 298 had been repeated, so it's only going to output that once. And when we use that inside of the length function, that's going to tell us how many there are. So that just did the job of us going and counting. So you can see what we have now is we have 18 unique birthdays of a group of 20. So that means that some of those people must have shared a birthday in the simulation. So now we can run this code sometimes, and you see now we get 20. This means that there were 20 unique birthdays, no one shared a birthday. Same here. Let's keep running it again. We have a match. Run it again. No match. We have a match. No match. No match. And we can keep doing this. And if we just wrote these numbers down, we could look for all the times there was a match versus all the times we ran this code. And again, that will give us an estimate of the probability. But now what we need to do is find a way of automating this process so we don't have to sit here and click this button a whole bunch of times.